13, we're denying the unique existential statement. So we're saying it's not the case that there's a unique x such that p of x is true, right? And for this denial, for it to be false, two things could happen here, and we have to make sure that we represent both of these scenarios. So either it's not the case that there exists a single x such that p of x, right? So either the truth set is non-empty, or it means that there exists an x and there exists a y such that p of x and p of y are true, right? So it means that there's no element, or either there's more than one element, and that's the way that we falsify it. So for A, we have either for all x, p of x, or for all x, not p of x. Now, and I'm just going to color code it. So this maybe I'm going to highlight it. So this part, for all x, not p of x, this certainly takes care of this one, right? So we're saying if for all x, not p of x, then certainly there does not exist an x such that p of x. Okay, but what about this part? For all x, p of x, right? Does this part take care of this part? Well, no, right? Because what if the universe only has one element? Then it's not the case that there's more than one element, which would make it false. So for A, we're going to say not a denial. Right? It is a denial. A is a denial of the existential, but it's not a denial of the unique existential. So that's that. Let's take care of B. So B, we have the case for all x, not p of x. So it takes care of the first scenario, right? It makes sure that in this scenario, it means that no elements exist for the truth set, or we have that there exist. Oh, and I should have said this. I should have put this here, where x does not equal to y, right? And for this one here, we have or there exists a y and there exists an x such that y is not equal, there exists a y and there exists a z, right? Such that y is not equal to z and p of y and p of z is true, which is what we wrote. So this perfectly takes care of the second scenario where it is true for multiple elements and these elements are not the same, right? So this is a denial. This is a denial. Okay, let's look at C. So C, we have that for all x, if p of x is true, so we're saying that if an element exists, then there exists a y such that p of y is true and x is not equal to y. Now, this does take care of both problems, right? Because we're saying if p of x is true, so if we have, if p of x is true, then that means that, and I actually should have drawn this in yellow. If p of x is true, then that means that p of y is true. And it means that p of y is not equal to p of x because x is not equal to y, right? So we took care of the scenario where they might have many elements and these elements are not the same. But what about the scenario where there does not exist a single person, right? Well, if there does not exist a single element, I mean, that makes p of x true, then this is clearly false, right? And if this is false, then this existential statement is true, because if the antecedent is false, then the whole conditional statement is true. So either way, if we have more than one element, or we have no elements, either way, this conditional statement is true. So C is a denial, right? And what about D? For D, we're saying that it is not the case that for all x and for all y, if P of X and P of Y is true, then X is equal to Y, right? So actually, because this is a little bit confusing, let's first translate this. Let's first just change this form. Now remember that when we're denying, so when we're going not all X P of X, this just means that there exists an X such that not P of X, right? So we're going to do this. We're going to change the universals into existentials. So we're saying there exists an X and there exists a Y such that, and to deny a conditional, we have to say P and not Q, right? So we have to say such that P of X and P of Y is true, right? The antecedent is true, and the consequent is false. That is how you deny a conditional. And the consequent is false, and X does not equal to Y. Okay. So in this case, we're saying, hey, there exist two elements that fit this property, that fit P of X, right? And these elements are distinct. So we have taken care of this situation here, right? But we have not taken care of the situation where E of X does not exist, right? P of X, there's no X such that P of X. So in this statement, we can't say that there's, it doesn't take care of that scenario. So this is not a useful denial, right? Because it doesn't take care of one of the possible scenarios. So in this one, we're going to say not a denial. So not a denial. So we saw that for item B and C took care of both scenarios, right? A had the scenario in blue, but not the scenario in yellow, and D had the scenario in yellow, but not the scenario in blue.